Alright, this video will go over the answers to the test you've just done on motion and force. Okay, so we'll start with the vocabulary. Okay, the term for the quantity representing the distance and direction of an object's position from a starting point is displacement. Newton's second law is not what this question asks. Sorry, I've made some changes to this test. This was third law. And Newton's third law says that if object A applies force to object B, then object B applies an equal and opposite force to object A. Then we had state what's meant by translational equilibrium. So that's when the net force on an object is 0. So net or total or resultant force. Then we had state, the term used to describe how close a measurement is to the true value, and the term for that is accuracy. The name of the fundamental SI unit used to measure temperature is Kelvin. Okay, and then we have the multi-choice questions. So the first one says a student measures the radius r of a circular plate to determine its area. The absolute uncertainty in r is delta r. What's the fractional uncertainty in the area of the plate? So area is given by pi r squared. So if we're going to square r, then we need to double the fractional uncertainty. So delta r fractional is equal to delta r over r. And because we're squaring, we're going to end up with so delta a fractional should be 2 times delta r over r. And we can ignore the constant when we're doing fractional uncertainties because everything is going to get scaled up by the same amount. So is that one of the options? Yes, it is. It's A. Two forces of magnitude 12 and 24 act at the same point. Which force cannot be the resultant of these forces? So we know that if we subtract one from the other, so if we have like 24 like this, and 12 this way, oops, I'll make it a bit shorter, 12 this way, then we're going to end up with a resultant force of 12. So the smallest value we can take is 12. And the biggest value we can take is 24 plus 12, which is 36. So the value that we want is going to be somewhere, values that we can get are any values between 12 and 36, basically. So all of these are between 12 and 36. This one is not, so it's A. A ball is thrown upwards at an angle to the horizontal. Air resistance is negligible. Which statement about the motion of the ball is correct? The acceleration of the ball changes during its flight. That's not true because the acceleration is always 9.81 meters per second downwards. The velocity of the ball changes during its flight. This must be true because it is accelerating throughout its flight at 9.81 meters per second downwards. Let's just check that the other two are wrong. The acceleration of the ball is 0 at the highest point. That's wrong, it's always 9.81. The velocity of the ball is 0 at the highest point. That's also wrong. That would be correct if it were launched straight upwards, but it was thrown at an angle, which means that it will have some horizontal velocity at the highest point. Okay, this graph shows the variation of velocity of a body with time along a straight line. Okay, A says the maximum acceleration is at P. Well, that's not true, because the maximum acceleration is when it's the steepest, and it's steeper after P, so it's not that one. The average acceleration of the body is given by the area enclosed by the graph and time axis. That's not true, because acceleration is the gradient. The maximum displacement is at Q. That's not true, because it has moved backwards for all this time. So it's been moving back towards the starting point for all that time. So that's not true. The maximum displacement would be at this point, when it's been moving forwards for the longest. The total displacement of the body is given by the area enclosed by the graph and the time axis. Yes, that's correct. So if we take this area, A1, and we subtract A2, then we'll get the total displacement. A boy throws a ball horizontally at a speed of 15 meters per second from the top of a cliff that is 80 meters above the surface of the sea. Air resistance is negligible. What is the distance from the bottom of the cliff to the point where the ball lands in the sea? So it was thrown horizontally, and we want to figure out how far it's gone. So the time we find by using S equals UT plus half AT squared. And because it was launched horizontally, U is 0, so that goes away. So T is going to be equal to 2S over A square root, which is, well, 2S is 160. That's the square root of 160, and G, acceleration, is about 10. So that's 16. That's the square root of 16, which is 4 seconds. And then we want to figure out how far it goes in 4 seconds. So Sx is going to be equal to 4 times 15, which was the horizontal speed. So that's 60. Number 6, we have a truck has an initial speed of 20 meters per second and it decelerates at 4 meters per second. What's the distance taken for the truck to stop? So we know U equals 20, V equals 0, A equals -4, and we want to find S. So we'll use the equation V squared equals U squared plus 2AS, and V is 0, so we then get 0 is equal to 20 squared plus 2 times -4 times S. So S is going to be equal to 20 squared, which is 400, over, -400, over 2 times -4, which is -8. So that is 50 meters. That's C. Okay, then we have 2 blocks, X and Y, rest on a frictionless horizontal surface, as shown. Which free body diagram shows the frictional forces between the 2 blocks? Well, we know that Y is going to be pulling X forward, so if we draw a free body diagram of X, we know the frictional force is going to be that way. And by Newton's third law, therefore, there should be an equal and opposite force acting in the same place, but on Y. So that's the direction of the friction on Y. So basically, Y is going to cause X to accelerate forwards, and X is going to reduce the net force on Y, making the acceleration of Y less than it would have been if that friction force hadn't been there. So X is forwards, Y is backwards. That's A. Okay, note that in your assessment, these answers would have been rejumbled, so you would have needed to find the correct answer. Okay. We have 3 forces acting at a point. In which diagram is the point in equilibrium? So the trick here is to figure out which diagram would result in a closed triangle. And this one would be that, that, and that. So that's never going to be a closed triangle. This one looks feasible. Let's have a look. It would be that, and that, and that. So that one is possible. Let's have a look at the other ones to check that they're not reasonable. So this one would look like this. So that's clearly not a closed triangle, so clearly not equilibrium. This one would look like this. So that's also not right. So it's definitely B. Okay, so equilibrium means the net force is 0, which means that when we add the three forces together, we must get a closed triangle so that the force that goes from the tail of the first to the head of the last will have no length, no magnitude. Okay, now we come to the longer answer questions. And this first one was a bit awkward on the sketch pad, I realized, but there wasn't really another way to do it. So, okay, so the weight force here is going to be straight downwards. That's the only force that isn't really labeled on here. You could have written FW, you could have written weight, or you could have written force due to gravity. Note that just gravity is never enough in an answer to these questions, because gravity could mean acceleration as well. Calculate the magnitude of the normal reaction force acting on the skier. Okay, so the normal reaction force, if we draw a little vector diagram here, we have F weight, and this is the normal reaction force. And we'll draw a little line to close that off. That line would be at the same angle as the slope. This angle here is 12 degrees, and this is the normal reaction, Fn. So Fn is going to be equal to F weight times cos of 12, which is equal to, we have 73 kilograms, 73 times 9.81 times cos of 12, which is 73 times 9.81 times 12 cosine gives us 700.48. 700.48 newtons, and it should be to two significant figures, so that's really 7.0 times 10 to the 2 newtons. Okay, and it asks us just for the magnitude, so we don't need to worry about direction. Okay, the next one asks us for the total frictional force acting. No, it asks us for the total tension force if the friction force is 65 newtons. This is probably the hardest question in this paper, I think. So you needed to recognize here that the force diagram would look like this. We have the weight force, we have the support force, or the normal reaction force, and we have a friction force acting this way. Then we know if the skier is moving at a constant speed, we know the net force must be 0, so the net force must be this long. Oh, sorry, the tension force. So what is that? That's this little bit of the right triangle here, plus the friction force. So this one's 65. So we just need to figure out what this bit is. And then 65 plus that bit should be the total tension force. So let's do that. So F tension is going to be equal to F friction plus F weight times sine 12. Let's go back up to the diagram. This little bit here, if this is 12 degrees and this is F weight, that little bit is the opposite side of the triangle. So that divided by the weight should be sine of 12. So the weight times sine of 12 should be that little bit. So that is equal to 65 plus F weight was 73 times 9.81 times 12 sine is that. And then we add 65 to that, and we get 213.89. Oops, I'll just finish off what I was writing. So the first number there was 148.89. So that is 213.89 newtons, which is the two significant figures. That would just be 2.1 times 10 to the 2 newtons. I recommend always writing, when you're rounding like this, just write the unrounded number first, just to show that all your working is correct. And a number of you didn't show any working at all, which is very risky. because if you don't get the right answer, then you can't get any credit for that question at all. Okay. We then have explain using Newton's first law of motion why the resultant force on the skier must be 0. The key hint here to answering this question was that he's going at a steady velocity, which means constant velocity. So we'll say Newton's first law says that an object does not accelerate if net force is 0. The skier is moving at a steady velocity, i.e. not accelerating, so net force is 0. Okay, so key here to get the full marks was to first show that you know what Newton's first law is, and then to link it to the problem. Question 2, we have a projectile that's launched horizontally here, so it's going to go like this and hit the water somewhere or the ground. State the magnitude of the horizontal component of acceleration of the ball after it leaves the cliff. So 0 meters per second squared. The only force is vertical. State, you just need to give the answer, you don't need any explanation. So it's 0 meters per second squared. On the axes below, sketch graphs to show how the horizontal and vertical components of the velocity of the ball, Vx and Vy, change with time. Okay, so Vx, we saw that it was launched at 5 meters per second. It's just going to stay at 5 meters per second because it doesn't accelerate horizontally at all. And Vy, well, vertically it's traveling, initially it's just traveling horizontally, so it's going to start off at 0. And then depending whether you call down positive or negative, you're going to have a straight line. Probably the most sensible straight line would look like this. And it'll be straight because the acceleration is constant, and the gradient of a velocity time graph is the acceleration, so the gradient must be constant. Note that you got full marks if you drew a line that went upwards as well, because whether you choose up or down to be negative is a bit arbitrary. Calculate the time taken for the ball to reach the ground. Okay, so it was 110 meters above the ground to begin with, and it started off traveling only horizontally, so we just need to figure out, using the vertical information, how long it takes to drop 110 meters. So we can say S equals 110, A equals 9.81. Let's give our signs the same conventions that we've been using. Meters per second squared, so it's going to fall downwards 110 meters, that's negative. It's going to accelerate downwards at 9.81 meters per second squared. We also know that U is 0, and we want to find time. So we can use the equation, which one do we use here? We use S is equal to ut plus half at squared. And u is 0, so that cancels. So we can say then that negative 110 is equal to, in fact, let's just rearrange it for t first. So we get t is equal to 2s over a square root, which is equal to the square root of 2 times 110 over 9.81. Well, negative and negative, not that it matters. Okay, so then we get a final answer of 2 times 110 divided by 9.81, and then we'll square root that and get 4.74. I'm going to write it unrounded. Seconds, and we were given things to how many significant figures here? 2. So our final answer should be equal to 4.7 seconds. Calculate the horizontal distance traveled by the ball until just before it reaches the ground. Well, horizontally it's not accelerating, so we can use the fact that Vx is equal to 5 meters per second, and t is equal to 4.7 seconds, and v is equal to s over t. So s is equal to v times t, which is equal to 5 times 4.7. And when we do this on the calculator, we'll use this unrounded number. It's 23.67 meters, and that is equal to 24 meters to 2SF. Alright, and then the final question. We have a projectile launched at an angle to the ground. In the absence of air resistance, it follows the parabolic path shown below. Sketch the path that the projectile would follow if air resistance were not negligible. So we want a lower max height, we want a shorter range, and we want an asymmetry in the graph. So it should look something like this. I'm kind of exaggerating everything here. Basically, the second half, so after reaching the highest point, that bit's got to be shorter than the first half, and the max height has got to be lower than the previous max height, and the range has got to be shorter than the previous range. Okay, so hopefully that's all clear. I do recommend that you go through the questions where you kind of got the wrong answer and try to figure out why you were wrong, and then maybe do a few practice problems on that topic from either the textbook or from Cognity.